function f of x is equal to x squared for x greater than or equal to 0, and its inverse, f inverse, is equal to the square root of x minus 2, we want to graph both the function and its inverse. So we're going to start with the function f of x is equal to x squared plus 2 for x greater than or equal to 0. This constraint is telling me the choice of x values that I have, or the domain of the function. So I can pick anything from 0 or greater. Now, there's a couple of approaches here. I have the square family, or x squared. So I can use the idea that this is a parabola and it's been shifted up 2 units because of the plus 2 here outside the function. But I can also make a table of values. I'm going to go ahead and do that. I'm going to write down a few values. So I list a t-table here, and I'm going to pick some values for x based on the constraint that x is greater than or equal to 0. So I'll pick 0, 1, and 2. And I'm going to take these values and I'm going to plug them into the function and get the corresponding second coordinates or y values. So for the first one, we have f of 0. Plugging that into our function here, we have 0 squared plus 2, and that gives us the value of 2. So here's our first ordered pair, 0, 2. Next, I'll plug in a value of 1 for x, and plugging that into the function, I have 1 squared plus 2, and 1 squared is 1 plus 2, which gives us 3. So another ordered pair on our graph is the point 1, 3. Next, I'll plug in the value of 2. In doing so, I have 2 squared plus 2. 2 squared is going to give me 4 plus 2 for a total of 6. And I have a third point of 2, 6. So I'm going to go ahead and graph these points and see what we have going on here. Keeping in mind that the only x values I have are greater than or equal to 0. So I've gone ahead and put down the coordinate system here, plotting the point 0, 2. That's our point right here. And then 1, 3. That's approximately right here. And 2, 6. So 3, 4, 5, and 6. So since we have the constraint on our x values, we have the right-hand side of a parabola whose vertex is at 0, 2. And I'll label some of these other points that we plotted. So this point was 1, 3, and this point here was 2, 6. And now I want to talk about the domain and range of the graph that I just plotted. So the domain, as I mentioned earlier, we only had the values of x greater than or equal to 0. So the domain are all values from 0 to infinity. Okay? And we're using an inclusion on 0 because it's greater than or equal to 0. The range, or the corresponding y values, or second coordinates. And if I look at the graph and I read it from bottom to top, the smallest y value that we have there is 2. And that point is included on our graph. So the range is 2 to infinity. So the next thing that I want to consider is the inverse function. And the inverse function is f of x, f inverse of x is equal to the square root of x minus 2. Now, one thing I know about a function and its inverse are the domain and range are reversed. So if I know the domain and range of the function, then for the inverse function, the domain will be the range that I had for the function. So the domain is 2 to infinity, and the range will be the domain that I had listed for the original function. So 0 to infinity. I could also look at the inverse function itself and consider what's underneath the square root. That is the x minus 2. It needs to be greater than or equal to 0. So solving this for x by adding 2 to both sides, I would get x is greater than or equal to 2. So that tells me my domain is also x is greater than or equal to 2, which is what I have written here. The next thing I'd like to do is to look at this function and make a table of values. The values that I can choose are 2 to infinity. So if I'm making a table of values, I'll select 2 to begin, and I'll do a function evaluation. So f inverse of 2 is equal to, plugging in 2 into the inverse function gives us 2 minus 2, or the square root of 0, which is 0. And so here we have the ordered pair 2, 0. What I'd like to notice is I have the ordered pair 2, 0 here, and for the function f, I have the ordered pair 0, 2. So that will happen, that our x and y values will be reversed. The next value I'd like to plug in for x is 3. So f inverse of 3 is equal to the square root of, I'm plugging it into the inverse function here, 3 minus 2, which gives us 3 minus 2 is 1, the square root of 1, which is 1. And now I have the ordered pair 3, 1. Again, comparing that to what I had with the original function f, we have 3, 1 here, and we have 1, 3 here. I'm going to do one more point. I'm going to look over here, and I'm going to plug in the value of 6. If I plug in the value of 6, we have f inverse of 6 is equal to the square root, 6 minus 2, 6 minus 2, which is 4, and the square root of 4 is 2. And so we have the ordered pair 6, 2. Here we had the ordered pair 2, 6. I'm going to go ahead and plot those 3 points over here on our graph. So I have the ordered pair 2, 0. I have the ordered pair 3, 1. And I have the ordered pair 6, 2. So 1, 2, 3, 4, 5, 6, 2. And here is the graph of f inverse of x. So this is f inverse, and this is our graph of f. And these two graphs are symmetric with respect to the line that bisects quadrant 1 and quadrant 3. This is the line y is equal to x. So this is an example of graphing a function and its inverse and showing they are symmetric with respect to the line y is equal to x.